I love
Now I'm starting.
We have been working with multiplying and dividing with exponents. So when you multiply, what do you do with your exponents?
You add them.
And if you're dividing, what do you do?
Subtract.
All right. Now, we're going to look today at scientific notation and standard form. So I know that y'all have worked with this before, and I just want to say up front, if you move to the right, that doesn't, the decimal point, that doesn't mean automatically a positive exponent. And moving to the left does not mean automatically a negative exponent. So let's stay together, and so that will help you to understand the difference between the two. So we are rewriting the first part in standard notation, which means we're getting rid of the times 10 or to whatever, and just coming up with a big old number. So the exponent for number 1 is a 5. And it's all of the scientific is going to be, 10 to some exponent. Oh, first, what's the purpose for scientific notation?
So you don't have to write such a long number.
All right, so if we're talking about miles from here to maybe Pluto's moon, that's like gazillions of miles. Or if we're looking under a microscope and we see this little bitty thing that is so little we can hardly see it with a microscope, it's ways for us to take little bitty numbers and really big numbers and have a uniform way to share them and to discuss them scientifically and mathematically. So, because it's times 10, I love this, the exponent is how many times you move move the decimal point. So, the first one, 3.65 times 10 to the 5th, means we're going to move the decimal point 5 places, and yes, to the right. So, how many zeros will we put in our answer?
3.
Yes, because it's moving past 6 and 5. Don't just put 3, 6, 5 and slap 5 zeros down. Take into account how many places you're moving that's already in decimal land. And then I highly encourage you to use the commas so that you can kind of double check that you have the right number of zeros. So then you do number 2. How many zeros are we going to put?
3.
And are we going to have a whole number or a decimal number? Decimal. And so we're moving it 4 places, but we already have a 7 over there. 1, 2, 3. 7. 02. Again, I did not say this a minute ago. I meant to. When you're in scientific notation, the largest place value spot is the ones place. Every other number is going to be in decimal land. Okay? So you won't have 30.4. It would need to be 3.04. All right. What about number 5? What would we have as that answer?
Be the same thing.
But it's times 10 to
But that's a 1.
any number to the 0 makes that number a 1. So, and any number times 1 is that number. So 5.91. Good. All right, and then number 6.
0.799.
Yes, we're just moving it one place to the left. 0.799.
Do you care if we add the 0 before the decimal?
No, ma'am. I don't. Good question. All right, are you good with this part?
Yeah.
All right, now let's look at changing them into scientific notation. This is where it can be, where I don't want you to just, because we went to the left, make it negative, to the right, positive. So look at number 10. Where should the decimal go for it?
Behind the 4.
Behind the 4. So we're going to make that 4.56. Everybody good with that?
Yeah.
Now, here's the question. The original number, which is the problem number, versus 4.56. Which one's larger?
4.56.
Yes. So our original number is actually smaller than the scientific number. But we need these numbers to equal each other. Therefore, we need to use a negative exponent, so that if we were to change it back, we would be back in the decimal land and not a really big positive number. So what will be our exponent? How many places are we having to move?
-6.
Times 10 to the,
Or 7.
no, we're going to get 5. You're going between the 4 and the 5, so times 10 to the -5. Does that make sense? Even though we move to the right, it's still going to be a negative exponent because our original number is smaller.
I'm a little bit confused. Is this?
Okay, you're comparing 4.56 is the number we have to use.
Yes.
But we need to make it equal a little bitty number. So if we used a positive exponent, it would move to the right and make the number grow like really big. But it's got to equal your 0.0000456. So your standard number is a lot smaller than your scientific number. So the scientific number has to have a negative exponent so that they can be the same number. They're representing the same. So it's just comparing your standard with what you'll use for scientific to figure it out. Does that make more sense? Okay. Yes, ma'am.
Is this the only time where we'll be like actually writing at the multiplication something? Because you said we weren't doing it in this class.
Probably. Then number 11, yeah, and then we're going to have negative exponents, which I've said, we're not doing negative exponents, but here we are. All right, 11, what would your answer be?
1 times -2.
So we just need it to be 1, or you could have 1.0, but you're moving it, the decimal point to the right, but I need it to stay a small number. So it's going to be to the -5. Is that clicking?
Yes.
All righty. Look at number 12. What's the scientific number going to be?
5.9.
And what's our exponent? 10 to the 8th. Okay, look at 16. It's in scientific notation, except what's wrong with it?
You have to put it back.
No, number
You
16.
have to fix it.
What's wrong with it?
It's not, the decimal's not.
We don't have a decimal. Where should it be?
4.3.
All right, here's what I want you to consider doing when you're faced with this. You figured out what was wrong. The whole number part is too big. We have to write it 4.33. So I would suggest that you take this number and put it into standard form. So we're going to add how many zeros? 4. So I'm going to put 4, 3, 3, and then 0, 0, 0, 0. That's the standard form. Scientific, you've already said it needs to be 4.33. So what's our exponent going to be?
6.
Times 10 to the 6th. Good. What about 17? You work it. What should the number be? The 4.2. Okay. And what'd you get for the exponent? -6. Good. So far, so good? All right, go to the next page, please. Now we're going to be using operations. This is where we're remembering that if we are multiplying, we're adding exponents. If we're dividing, we're subtracting exponents. And it says in the directions your answers need to be in scientific form as well as standard notation. So here's where your handy dandy comes into play. You're going to take the numbers and divide them first. We won't even worry about the 10 to the whatever exponent. So tell me what we get when we say 1.4 divided by 2. 0.7. Is that a a scientific notation number? Is it ready? No. So we have to rewrite it. What should it say? 7 times what?
7 times 10 to the 5th.
No. 0.7. I need to rewrite 0.7.
7 times 10 to the negative 9.
7 times 10 to the negative 1. That's all we're working with at this point, is getting your number to be correct. We can't use 0.7, so we have to rewrite it. Are y'all good with how we rewrote it?
Yeah.
With the negative 1. Now we go look at our exponent part. And we say 4 minus 2. What is that? 2. So we're going to then multiply that by 10 squared. So we know 7. And then what would our exponent be?
-2.
What is negative 1 plus 2?
Oh,
1. Remember, add your exponents. So negative 1 plus 2. So then, or if you happen to move it down, you would have 2 minus 1. So what is our standard form?
Just 70.
70. Does that make sense? Yes? No? Maybe so?
So when it asks for give both the scientific and standard notation.
Got to give me 2 answers.
Yes.
So look at number 2. What do you get when you divide? 3 divided by 2.
The decimal.
1.5.
1.5. So is that in a form that can be used for scientific notation?
Yeah.
Yes, sir.
So we don't have to do any changing of it, but we have to deal with the exponents. Now, there's 2 ways to do this. How do we make negative exponents positive? Flip them. So there's 2 ways we could handle this. You could move that, the 15 up and the 12 down, making them positive. And then you subtract. What's 15 minus 12?
3.
Times 10 to the 3, to the third. The other way is actually doing the math of negative 12 minus negative 15. And what does that give us? 3. So either way, you would get 3 as your exponent. Then, what is that in standard form?
1,000.
So we're going to have how many zeros?
2.
2. 1,500.
Oh yeah.
Carlin.
I have a question. Why is 1.5 ready to be like notated in scientific notation with 0.7?
Because for scientific notation, we have to have one whole number. It has to be a number in the ones place other than 0. And we can't have 45. We can't have a number like in the tens or the hundreds, but we have to have one whole number there. All right. Look at number 15. I'm sorry, number 5. Number 5. What do? This is a different setup.
7 times.
Yep.
1.7 times.
You're going to multiply. And what do we get when we multiply?
16.7.
Yes, we do. Is that scientifically set up?
No.
So it needs to be rewritten as 1.617 times 10 to the negative 1. No. What do we do with our exponents?
Multiply.
Add them. Because we're multiplying, and so then we're going to add our exponents. What's 5 plus 2? So it's 10 to the 7th. So what would our final answer be? 10 to the 6th. So 1.617 times 10 to the 6th. And how many zeros will we have on our answer? 1617 0 0 0. And there's our big old boy number.
Where'd you get the negative 1 from?
Yeah, where'd you get that?
Okay, we're at, it should be, no, it's got to be a positive 1. It's going to be a positive 1, and that's going to be 8.
Get the 1.
All right, so it's 16.17,
Yeah.
but it needs to be 1.67.
Oh, so you have to times
Yeah, so we had to, it's going to be a smaller number than our original. So it's going to be times 10 to the 1st.
So you have to multiply it in order to change
Yes, so that we have it. Yes, ma'am. So that this has to equal 16.17 when we put it in standard form. So that means, I apologize, this should be 8, not a 6. Right here. And we're going to have one more 0. And which means that's wrong and that's wrong. Are y'all comfortable with the change we just made? And why? Are y'all good? All right, I have y'all looking at me funny.
Don't we need another
I
zero?
thought there was 3 zeros.
Don't we need one more?
1, 2, 3, 4, 5, 6, 7, 8. Yep, we gotta have even one more 0. Hold on, let me
Wait,
put that
how
over
did
there.
we get 8?
1 plus 7 is 8. Take that out and that out.
It was.
But it was a negative.
It's supposed to be a positive.
She messed up.
I messed up. No, cancel, don't change it. Because I was going along too fast.
I see that.
Because we were at 16.17.
And you moved it.
And we made a smaller number that's got to grow to get to 16.
I see.
And then we moved it 3 places, but we got to move it 5 more. 3, 4, 5. This number just keeps getting bigger and bigger. You tackle 7 and 8. What's your exponent for number 7? 1.
Did you get 49?
4.95?
Yeah.
Yeah. So you didn't have to change it. So that means 49.5. And then what about number 8?
300.
3 times 10 to the second, which gives us 300.
Is the homework the ones we didn't get done?
Nope, that does sound like it would be.